Hello everyone. Thank you for being present at this talk. I'm Subhajit Das, PhD student from Georgia Tech, USA. Today I will talk about our paper InMacs, Interactive Modeling and Comparison of Sentiments from Sequence Data. Machine learning has impacted many domains. For example, urban planners use machine learning to model public opinion from tweet posts and compare people's sentiments and topic of discussion from multiple geolocations. To improve this workflow, we work closely with planners to design an interactive tool for their data analytic goals. From repeated discussions, we learned that these users either work with a data analyst or reuse codes from the web to build their model, but more frequently they use AutoML-based solutions. For example, they specify a pre-annotated dataset of tweet corpus to AutoML to train a sentiment classifier. While useful, urban planners find the current workflow inhibits them to incorporate their domain expertise in the modeling process. Further, they cannot refine and explore multiple models by adjusting training examples or input features incrementally. To resolve these problems, we designed InMacs, which empowers urban planners to interactively construct sentiment classifiers and topic models. It also helps them visually compare and explore the results from multiple models to test various hypotheses. And it also helps them to provide incremental feedback to AutoML by adjusting data instances and its features. InMacs user interface comprises of a collection of heat maps to compare topics and categories of text documents across multiple geolocations. The color encodes number of tweets from a topic and a category, such as land use type in urban planning. A temporal view showing a histogram of number of text documents on a timeline. A model overview panel showing thumbnail previews of models prediction. Users can click on any cell of the heat map to see a text view, which lists text documents for interactive text preprocessing. Sentiment classifiers results are shown as a confusion matrix view with associated metrics. It also shows a histogram along the time axis, highlighting number of correct and incorrect prediction of sentiment labels. Topics are shown using a clustered node representation. Further, a set of word clouds show most common keywords, and a linked bar chart shows top keywords per topic. User feedback is provided by removing noisy data, updating labels, deleting text or part of the text, replacing keywords, or specifying text length. Users can do these operations through the text view by clicking associated buttons or pushing or brushing their mouse to highlight part of the text that needs preprocessing. The text corpus is first preprocessed using standard NLP techniques such as tokenization, stemming, stop word removal, etc. The heat maps are represented as topic context matrix M. Users can further specify preprocessing on this matrix to adjust behavior of the model. For example, from the matrix M, users can explore multiple topics and keywords. They can discard or like topics that are relatable to their domain. Each such interaction adjusts the token weight with the bag of words representation of the text corpus, thus directly steering underlying models. For further details, please read the paper. As users interact with InMacs, under the hood the system utilizes HyperOpt as the AutoML solver. It builds multiple topic models and sentiment classifiers by sampling a pre-specified list of hyperparameters and then checks the model's effectiveness based on metrics derived from user interaction. From these models, HyperOpt chooses the best model and then applies the results of this model on the training and test set. Finally, it visualizes the results for users to spot check their correctness. Let's see how users can interact with InMacs using Twitter datasets. The heat maps show which topic and category tweets are more frequent, and the timeline view shows temporal evolution of tweets of a topic and a category. They are placed next to one another to aid comparison of multiple geolocations and to find missing data that are seen in the timeline view. The text view finds incorrect predictions, noisy data in relation to annotated sentiments, topic, and the category such as land use in urban planning. The Model Overview panel on the bottom shows topic and sentiment models results across multiple iterations. Users can click on any thumbnail to switch to a different iteration point. Topics and weighted keywords are shown next to each other to inspect their correctness. Users can hover over nodes to see top keywords for that specific topic. Sentiment classifier results can be assessed to the confusion matrix and other metrics such as precision recall. The histogram shows correct and incorrect predictions across time, highlighting any pattern. Users can search for tweets by keywords and then directly pre-process the data through the text view. To summarize, we presented InMacs and findings from a design study with urban planners to help testing various hypotheses. In the paper, we also presented a use case with a Yelp review dataset showing the generalizability of the tool on other problem cases. Thanks for listening. I'm looking for a full-time position. Please contact me to talk more.